Today I'm going to be telling what exactly is an atom, as I've heard that there's a lot of confusion for sixth graders. So what exactly is an atom? So an atom, here is the definition. An atom is the tiniest particle which makes up everything. So a atom makes up everything, even you, this paper, everything. Atom is very, very essential because it makes up everything. Right. Now, you might have a question, and many people are also interested, that who actually discovered atom? Obviously, as I told you, atom is very, very essential. Now, who discovered it? Who was so clever to discover it? So the answer is John Dalton. John Dalton was a scientist who discovered atom. So what exactly was John Dalton's thinking was that like everything is made is like this paper itself. Why is it solid? Why is it solid? So he did experiments, and he found out that there are particles that make up everything, and they're called atoms. And he had a thinking that atoms were snooker balls. They were like snooker balls. And he said the atom cannot be broken, just like snooker balls. So he referred to snooker balls. Later, another scientist discovered subatomic particles. Now, before I tell you what are subatomic particles actually, I am going to be telling you the scientist's name. And remember, he discovered subatomic particles obviously after John Dalton. So this scientist's name, I know most of you know, J.J. Thomson. J.J. Thomson was a scientist who discovered subatomic particles. Now I'm going to tell you what exactly are subatomic particles. Subatomic particles are particles which are inside an atom. Now you might be very surprised because an atom itself is very small, as this is what a definition. This is the definition. An atom is the tiniest. Can you see this word tiniest? So it's very tiny, right? So now the things which are inside it must be even tinier, because if it needs to fit, it should be even tinier. So this scientist J.J. Thomson found subatomic particle. So again, I told you, subatomic particles are particles which are inside an atom. And now there are three main type of particles. What are those? Now those three types of particles are electron, proton, and neutron. These are the three main particles. Okay, so I'm going to be telling you again. So now, again, I'm going to be telling you what exactly the three main. So they are, as I mentioned, it's proton. So this is number one. Number two is neutron. Proton, neutron, and then the third one, which is electron. So these are the three main subatomic particles. these are the subatomic particles. The subatomic particles. So there are only 3, okay? And I am gonna be telling more about it. But first, I want you guys to look at a structure of an atom. Okay, so this is the structure of the atom. This is what an atom looks like. We have never seen an atom. Now, latest 2020, now they've found out how an atom looks, but before that, we didn't know how it looks. So scientists said that after a lot of experiments, they found out that this is how a atom looks. This is what they thought it looked like, and they found out by a new discovery that yes, it is this way. But very few scientists have seen how an atom looks, so it's not final. So now you see this thing in the middle, right? Now this is a nucleus. Now nucleus, I know you all must know what a nucleus is, because you guys must have studied cells, and cells also have an atom. So, sorry, not an atom, a nucleus. Now, you know what a nucleus does. The nucleus is the control center of the whole structure. So this is an atom, and the nucleus is also like the control center. Now, I'm going to be talking about this structure. Now, you see these red dots in the nucleus and the blue dots in the nucleus. Now, the red dots are the protons, and the blue dots is the neutron. So, the red dot is the proton, and the blue dot is the neutron, and these 3 black dots here is the electron. So, now, again, it's the same thing here that I mentioned. Proton, neutron, electron. So the same things are in this atom structure. Proton, neutron, electron. All of these 3 structures are here in the atom, but they are in different places. Now you can see the proton and the neutron are in the nucleus, and the electrons are outside of the nucleus. Now you guys might have a question that what are these black circles that I have made? These black circles are just imaginary lines, right, on which these electrons are. These are just imaginary lines. This represents the orbit of these electrons around the nucleus. So this is not in an atom structure. It's not actually, there's no actual orbit or line like this. There is just the atom. And why we have drawn this line is because the electrons are going real fast around the nucleus, and like real fast. They're like bees buzzing around the nucleus. It's just like, when you get an electric current, how fast and quick that is. It's like a fizz going around. So this is why I have drawn these circles. These circles represent the movement of the electrons. Now you see the protons and the neutrons do not have any orbit or movement. They just sit there still in the nucleus. Like that. In the nucleus, they just sit like that. So you see the proton and the neutrons are just sitting still there in the nucleus. Now, before I move on, I want to mention a few more things. So let's move the atomic structure aside. And now back here. So I told you proton, neutron, and electron. But this is not it. Now there are more things here. Now you need to know more separately about each and every subatomic particle. So remember, all these, the proton, neutron, and electron, all of them are subatomic particles. Now the proton, neutron, electron, they all have charges. Now I hope you guys know what a charge is, because like a charge is electronegativity, right? So a proton is positively charged, okay? Whereas the neutron has zero charge. So the neutron has no charge at all. So I'm going to be writing a 0 here. Whereas the electron is negatively charged. So now that you know the charges of the subatomic particles and you know where they are. So again, let me recap. The proton and neutron are in the nucleus. The electron is outside the nucleus, and these are the charges. Proton is positively charged, and neutron is no charge at all, like 0, and electron is negatively charged. Now let's move back to our atom structure. Now that you know that the proton is positively charged, neutron has no charge, and electron is negatively charged, I know you guys have a lot of questions, but before you ask, let me just solve them. Now, you might have a question that if the proton is positively charged and the electrons are negatively charged and the neutron has no charge. Now, why isn't it so that the proton, if you guys don't know, let me just mention this to you, that opposite charges attract. Some people might know this and some people might not, but for the people who do not, I'm just recapping this for you. Opposite charges attract. Now, opposite charges are like positive and negative charges. Like, it's not like positive and negative will attract to each other. Like, they will attract, attract. But positive and positive will repel. They want to go farther and farther away. So they're pushing. And same goes for negative. Negative and negative repel. So now back to the atomic structure. You might have a question that why doesn't the proton go up to the electron and start buzzing with it? Because you know that proton is positively charged and electron is negatively charged, so they should attract. And the answer is yes, they do attract. But now there's another question arises. Why doesn't the proton go up to the electron and start buzzing? They attract. But that's not happening. Now, the thing is that that the neutron has no charge at all. But then what is it doing in the nucleus? That is another question which I'm going to solve. So first, let me tell that the proton and electron the proton does not buzz around. So before I move on, just think of this. The nucleus is a special room in which the proton and neutron are in there and the electrons are out. Okay? Now the neutron has no charge at all, right? So the neutrons basically keep the proton in the nucleus. They prevent it from going up to the electron, getting out of the nucleus. Now, how does it do that? Now that I'm also going to explain. Let's get back here. Now, I told you we have to focus on all of these. Now there's another thing. Okay. So now the electron, neutron, and proton. Now remember this. The proton has a weight. Its weight is 1 unit. It's exactly 1 unit. Whereas the neutron's weight is also 1 unit. So now you can see both of their weight is 1 unit. But whereas the electron's weight is a bit different. It's 1 over 1840 unit. Now what do I mean by 1 over 1840? It's like I have cut it into 1840 pieces. Now the weight of, out of those 1840 pieces, the weight of one of the piece is the weight of an electron. Can you imagine how small, how less is the weight compared to the proton and neutron? Now let's get back here. Now you see, there are 2 ways. One, if you remember a movie, I don't remember the name, but I think it was Pinocchio, in which one of the characters tied up stones to his belly or stomach to sink into the sea. So why did he tie up stones? So that he could sink. Same way, think of these neutrons as stones tied up to the proton so that they stay in the neutron. It's like a pin. Now, another thing is also that, they attract, right? But the neutrons in the middle come and they make the attraction less. So these are the 2 ways. This is why they do not attract. So now I've explained you that what an atom structure is and what the subatomic particles are and everything about them. Their weight, their charges. So this is all you need to know. But I want to explain you a bit more, which is that you can see this nucleus and the electrons. So now you know the electrons are out of the nucleus, right? But the electron is very, very far away from the nucleus. Now, I want to give you an idea of how far the electrons are. So, I'm going to be telling you how far the electrons are. Okay? So, they are very far. Let me tell you this much. But now I want to tell you an analogy, okay? So, this is what I've made. Now, you can see this. Imagine this as a football stadium. Okay, I know it's not good. But imagine this shading that I've done are people, okay? And then this little square here is the place where they are, playing the football game. Now, can you see this dot I have made in the center? Imagine this as the nucleus. And, far up here is the electron. So I know this is just a piece of paper, but I want you to visualize this. Imagine you're in a football stadium. And how far is it? Think of this as your parking lot. So, this is even the size of a pea. Imagine. So, just imagine. How far will it be? Here in the middle of the stadium. And then up there, in your car trunk, size of a pea in your trunk. How far is that? that's real far, right? Like, just think about it. Nucleus and electron, they're so far. But on a size of paper, you cannot draw it that far. So we just draw it like, normal size. Now, I'm going to be telling you a bit more about it. About the atom. And, okay. So I'm just going to be telling you a bit more. But I want you to remember one thing which is very, very important. The nucleus and the electrons are very far. This point should be kept in your mind because, this is also a cool fact that I like to know. So remember, the nucleus and electrons are very far. That means the proton and neutron are very far from the electron. Now, I'm going to be telling you a little more about atom. Okay, now this is a nucleus, okay? This is the nucleus, okay? Now, there should be electrons around it, right? So now we cannot always draw it like this pattern. So what we do is that we just add a shell. Sorry, it's just a bit messed up. But what we do exactly is that we add a shell. Like, this thing is called a shell. And these green dots that I've made is the electron. This is a shell, and these are the electrons, right? And now, another thing. There can be to the maximum. Like, there are like a lot of shells, but I'm just gonna be talking about 2 shells. So before I move on to the next shell, I just want to explain you a bit about the first shell. Now, in the first shell, you can only have 2 electrons. Now, you guys might have a question about the settings, but don't worry. Now, you know that I told you here that opposite charges repel. So here, the 2 electrons will repel. That's why if you see they're sitting in the farthest position they can. Farthest. So that's why there can be only 2. Now, in the second shell, here, this is the second shell. And as you can see, there are 8. For the second shell, there are 8. Now how? Now you see, the first 2 electrons sit, they're like, okay, they're very far. Second 2 electrons have no choice, they're like, fine, we'll choose the second farthest. Third one, they're like, space occupied, what can we do? Because they cannot go anywhere else, right? And then the other 2. This is how they're set. Now there are the maximum 3 shells, but we are only going to be studying about 2. And the second shell also has 3. So we're just going to be studying about 2. So this, I want you to remember this. Now I'm going to be mentioning a bit about the periodic table. Now, here is a periodic table. Now, remember, you see this way are groups, and this way are periods. Now, this part, I don't know if you can see, but I've shaded it with pencil. These are transition metals, which we are not going to be talking about. But why I mentioned the periodic table? This is the reason. Because the number of groups is the number of electrons in the outermost shell. Now, you see 1 here. The first group means all the atoms, the types of atoms in the first group have only 1 electron in the outermost shell. So on, like 2, 2 atoms. Then 3, 4, 5, 6, 7, 8, or 0. Remember, this last sign is 8 or 0. Now, periods. Now, this way are all periods. So, now it tells the number of shells in an atom. Now, all the atoms in the first period all have 1 shell. In the second period, all have 2 shells, and the third, then fourth, then fifth, sixth, seventh. Now, another thing which I wanted to mention is that, can you see this? I don't know if you guys can see, but I'm trying to make it clear here. So this is beryllium, and you can see 2 numbers at the top, one at the top, one at the bottom. 4 and 9, right? They're two. I'm sorry, but it's not showing clear. 4 and 9, beryllium. Now, what are these 2 numbers? This might be a question. Now, before I move on, I want to go back here. Now, you see that proton has 1 unit, neutron has, also 1. Now, proton is the identity of an atom. Why? Because the proton tells the weight. Okay? And the neutron is also part of the weight. So the weight is the identity of an atom. The electron is not the identity, because you can see the weight. So back to the periodic table. So now again, I'm trying to mention here that this number at the top is the atomic number. Okay? Or proton number. And this at the bottom is the atomic mass. Now, you guys might be confused, because in some and remember, this sign is the atomic symbol. So in some periodic tables, this number is written at the top and this number is written at the bottom. So you guys might get confused that which is atomic number, which is atomic mass, because I've learned that at the top it's atomic number and the bottom it's atomic mass. But easy. Remember, the bigger number is atomic mass. Now, why? This might be a question. Now, the reason is because you add proton and neutron together. So that would be a greater number than just proton number. Because, if, for example, there are 2 protons and 2 neutrons. So if you're going to be writing, so it's going to be like 2 over here, but 4 over here. Why? Because you're adding proton and neutron. Because as I told you here, the neutron also has weight. So they both are counted. Now, the electron is not counted, even though it has some weight. Why? It's like when you're weighing yourself on the weighing machine, you do not worry about the weight of the necklace or clothes or anything you're wearing, or a watch or anything. Why? Because it's so less that's negligible. You don't need to worry about that. So same goes for this. So this is why I wanted to mention the periodic table, just to clarify you. And so remember some points that this remember the scientist name, John Dalton, J.J. Thomson. Okay. Now, there was another scientist, Ernest Rutherford. I'm going to be telling you a bit about it. He found out that, so I forgot to tell you this, that atom is mostly air. Why? Because as I mentioned over here, this is why I told you that keep this in your mind. Nucleus and electrons are very far because atom is mostly air. Because can you see the space? So who found this out was Ernest Rutherford. He found out that atoms is mostly air. How? He did a gold foil experiment. So I'm going to be telling you what the gold foil experiment was here. So what he did, he took a piece of gold, which was very thick. So I'm just going to be drawing this thick. So you can refer how thick it is. And he was shooting an electron ray at it. So electrons were bouncing off. But then he shot at it and he saw that it passed through. So he was amazed. Now, he did it again, but it again bounced off. So it was only shooting in some directions. So after a lot of experiments, he found out that when he was shooting the electron ray, he was actually passing it here. When he was shooting, it was actually passing through this. But when it was bouncing off, it was actually hitting this, the nucleus. So now do you get, I hope you guys know what an atom is. And if you like my video, please subscribe and like, because I really want, please subscribe to my mom's channel because I'm posting this on my mom's channel. So please subscribe to it and like it because it motivates us to make more videos. And so have a great day and stay safe and healthy. Bye.